Let's take a look at how these connections and sockets are managed in the operating system. So here I've got a machine that has address 10.18.230.214, and this machine is going to act as my client. So it's connecting to some server, some other machine at port 22 using TCP, which creates a TCP socket, much like our previous pictures. We have a destination address, a destination port, and an ephemeral local port that represents that connection. Now the application could start sending data on this socket right away, but that data is not going to go anywhere until the server side agrees to connect it. And to get that process started, even before the application sends any data, the fact that it created this TCP connection causes a packet to go out that's a connection request to the server. This packet doesn't actually have any data in it, and the TCP header, we're setting this SYN flag, meaning synthesize a new connection. The TCP header has the source port, our ephemeral port on the client, and the destination port, and it has the server's destination address, and it has our machine's address as the source. That connection request will go out to a server, and then the application can start sending data over it. The application doesn't have to wait exactly. The operating system will wait until it knows that this connection is established before it actually starts sending data. But eventually we get into the state where the client can send data like cat_hello.txt, and we have these kinds of TCP headers and IP headers like we were talking about before. On the server side, so our server is 155.98.65.55, the server starts out, remember, by creating one of these listener sockets. So it'll do that with some sort of OS function provided by a language library that says create a listener at a particular port. And that creates a socket, but this socket is a bit like UDP in that it doesn't have a connection to anyone else yet. This is a socket that's just waiting to receive TCP connections. So all it has is a local port number. When that connection request that our client sent arrives at this machine, then the operating system sees that it's a connection request to a port number that does have a listener, and so the operating system will create a new socket that represents the connection to the client. So on the server side, we still have port number 22, and the other end of this TCP socket, the connection, is that client machine 10.18, etc., and that client ports number 1234. At this point, the socket representing the connection has been created. The operating system consumed that packet to create the socket, but the application doesn't yet know about this new socket. To actually get this socket, the application will need to perform an accept operation on the listener. And it could do that right after creating the listener. The TCP accept call will just wait until this newly created socket is available. When it is available, then the operating system will return that to the application, and now there's no particular connection left between the listener and the new socket that represents the connection. The connection is standalone now, and it can keep going as long as the client and server want to keep talking over it. The server can receive requests, it can send them out, so if it was asked to send back hello world, then it can do that. Again, with the source and destination of the sort that we were describing before. So the destination here is our 10.18 client number. It is possible that multiple clients connect to the server, and that will mean we have multiple sockets, each connected to a different remote address and remote port number. Locally, all of these sockets representing connections have the same port number. This is going to turn out to be okay because we can distinguish messages coming in based on the other end of the connection's port number. Since every TCP port on the client side represents a single connection to a single server, and since each of those sockets will have different port numbers, that's enough to keep the messages separate for these two different TCP connections. For example, if cat hello is coming in and is coming from source port 1234, then we know it's related to this socket and we can deliver it to the application through that socket and not through this other socket.